The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody. My name is Jarlath Quinn. I'm an analytics consultant here at Smart Vision Europe, and I'm joined online today by my colleague Rachel Clinton. Rachel will be making sure everybody's logged in correctly. This is a relatively new webinar we're running about a relatively new product for us. It's called PS Clementine Pro. And it's really an overview and an introduction to that product to give you a sense of what it does and how it fits together, etc. And there'll be a live demonstration. If you haven't joined any of our sessions before, and we run many different sessions online about many different topics and different tools, usually around the analytics and predictive analytics and data mining and all that sort of stuff. Just so that you're aware, we do record these sessions, so you can listen to them again afterwards. And there's a few slides that we show. It's mostly a demonstration, but we do send out a copy of the slides to you in PDF format after the session has ended. If you think it's particularly relevant or useful, and you think that some of your colleagues might be interested in it, it may be possible for us to rerun the session on a private basis, in which case just drop us an email and we'll see if we can arrange that. With regard to asking questions, well, unfortunately all the lines are muted, so we can't hear you. If you use the chat facility, we'll try and answer them as we're going along, and if we run out of time or are unable to answer any of those questions, of course, we will follow up with you offline afterwards. If you don't know who Smart Vision Europe are, we're a technology company, and we're a premier accredited partner to organizations like IBM, SPSS, and Predictive solutions. And we specialize in advanced analytics, big data technologies, machine learning, statistics, predictive analytics. We also work with open source technologies such as R, Python, and Spark. And as a small company, we're a team that is made up of people with 15 to 25 years of experience working within the advanced and predictive analytics space. So I've personally worked for IBM SPSS and SAS at some point in the past. As a result of that, we've got fairly deep experience of applied advanced analytics in lots of different sectors, including retail, insurance, utilities, communications, etc., etc. So today we're talking about PS Clementine Pro. But before we do so, we're going to talk a little bit about predictive analytics. Just going to set the scene here so we understand where this technology sits. If you're aware of what predictive analytics means, you can just ignore this part. But otherwise, just so that you're aware, predictive analytics is defined within Wikipedia as a paradigm, if you like, that encompasses a variety of statistical techniques from predictive modeling, machine learning, data mining that analyze current and historical facts to make predictions about future or otherwise unknown events. So your takeaway from that definition is really that predictive analytics and related approaches are very much a bag of different technologies and different traditions within analytics itself, whether it be classical statistics or machine learning or data science. So it's very much a banner term that covers all of these different types of advanced analytical techniques. We prefer to describe it in terms of a series of bullet points because we think it's hard to come up with a single all-encompassing definition of the term. So the point we like to make is that it is very different, of course, from business intelligence or management information reporting. It's not always about prediction. There are many times when you're using predictive analytics technologies to do things like anomaly detection or to segment and group people together or to do forecasting or text analytics. And certainly a PS Clementine Pro will cover all of those areas. However, predictive analytics does create important new data, and this is one of the things that makes it different from BI or MI. This new data takes the form of predictions normally, but often things like estimates, probability values, forecasts, recommendations, propensity scores, classifications or categorizations, and likelihood values such as anomaly scores or risk scores. And what we tend to do with those these new data is we tend to incorporate them in some way that we can make a good decision. So that might be sending those results to an operational system, could be something as simple as a database, or it could be that you're incorporating them into a outbound marketing campaign management system such as Unica, for example, or or some of the survey technologies. Or alternatively, you're looking at insight systems. Insight systems, by that we just mean the usual BI or MI platforms that you already have, the visualization platforms that you may have, whether it be Tableau or visual analytics from SAS or etc. In other words, we try to do something with these data to either drive deeper insight and or drive better decisions. And we'll see examples of how we actually create this data when we get to the live session. Okay, so what do we mean by PS Clementine Pro and why should people be interested in it? Well, PS Clementine Pro is an end-to-end platform for predictive analytics and the deployment of results developed and maintained by Predictive Solutions in Poland. And it includes in its entirety all of the analytical algorithms that you would encounter within the very popular IBM SPSS Modeler tool. Okay, so there's a number of additional functions and additional technologies that wrap around that really add a great deal of value to the analytical engine behind it, which is SPSS Modeler. It's a fully integrated environment, and it manages not just models, but lots of aspects of the analytical process, including things like what we call streams, the output, the evaluation of models, and it allows you to utilize various algorithms, including machine learning, classical statistical algorithms, and use these algorithms to solve hundreds of business problems, whether it be things like predicting flood risk for sewer pipes, for water utility, or failure of mobile phone masts, or people who are likely to not renew a contract, or individuals who are likely to sign up and become customers, or to identify anomalies or high-risk events. So there's lots and lots of different business applications that it's used, and certainly we within Smart Vision have quite a lot of experience of using tools like PS Clementine Pro to drive exactly those sorts of applications. But it's also able to archive and share models, streams, jobs, automated jobs, analytical output in its own dedicated solution repository. So it's got its own repository for storage and search and retrieval and sharing of these assets across other interested parties. On top of that, it allows for automated scheduling of jobs, of procedures. These procedures could be something that is predicting an outcome. They could be data preparation. They could be driving output and insight and creating charts. So lots of different types of jobs that could be run there. And the scheduling can either be time-based or event-based, as we'll see. There are also the opportunity there to do parameterized execution. So the execution is based on these jobs, based upon a parameter value, such as the month that you're running it in, or a particular flag field that is triggered. And it will even include email notifications. So notify you by email when a job has completed and whether it was successful or whether it has failed. There's a lot of additional sort of value-added elements there that really flesh out that solution and make it very much an end-to-end data mining platform. There are certain components to PS Clementine Pro. You'll see a little bit of this when we're doing the demonstration, but suffice to say, it starts with a desktop application, so the PS Desktop. That's a supporting program. It's a common hub application, if you like, for PS Predictive Solution products. Clementine Pro is one of a number of different products, and there's also another product called Imago Pro, which is uses the SPSS statistics engine in the background. And it allows you to open streams from the repository within the model application. It launches PS Clementine Manager, so it allows you to manage the environment, and it executes single set of jobs or directly from the repository, and will show you job history and the failure or success of jobs as and when they've been run. The Clementine Dispatcher is the actual scheduler tool. That's what we call the scheduler tool, and it does a similar thing. It allows you to create new jobs, to drag streams into jobs. We'll see examples of that and execute them in batch mode or based upon events that have occurred. And there's a lot of control over the frequency and the timing of those jobs, so you can run them on a daily basis, you can run them on a weekly basis, or quite a complicated set of circumstances where you say, I want to run it, I don't know, on the third Wednesday if every month, that type of thing. So it gives you quite a lot of control with regard to the scheduling itself. And it communicates, of course, directly with the PS Clementine repository or database to check if there are any tasks to do. The manager application, which I alluded to earlier on, allows us to manage the environment itself. So we're very conscious, of course, that not everybody is doing the same job when they're using these types of tools. Some people are working within the analytics realm. There are different levels of seniority. Some people are working within very much the data manipulation or the data transformation, things like ETL type tasks that one might be doing, the preparation of data. And these different groups, of course, and user types can be defined within the repository structure itself, so you can have control over who can see what and who can do what. It also allows us to open the streams in the repository. It has a search facility and allows us to do wildcard searches for different objects and object types within the repository, such as streams versus jobs. And it defines the schedules and managing of the analytical tasks. The PS Clementine repository itself is where we archive and control and store these assets, and allows versioning of the objects stored within the database. So you can mark an object as important, for example, to say that, this is my main version of this object, whereas other versions of the object, such as a stream, might just be sort of development, or where you're doing a test or an experiment at some point. And as such, it provides a repository for business users, people who aren't necessarily using the PS desktop application, the Clementine application itself, but who want to have access to those objects and maybe even execute the streams themselves, or to schedule them to be executed at a later time. So, for example, it provides a hub for people who aren't just analysts, but who are perhaps supervisors or who are team leaders, for example. So that's kind of how it puts together. Within PS Clementine Pro, in terms of the analytics itself, as with SPSS Modeler, we tend to group it into 3 different areas, which are predictive analytics or prediction algorithms, where we're trying to predict a category membership, so an outcome, a classifier, whether or not somebody churns, whether or not somebody defects to a customer, whether or not a failure has occurred, whether or not somebody is satisfied or unsatisfied, or predict a numeric value, such as claim amount or estimated claim amount, or estimated revenue from a particular line of business, etc., etc. But outside of the classic predictive machine learning and statistical predictive modeling tools, you have, of course, other algorithms that will look at, for example, grouping similar rows of data together, so segmentation and clustering, for example, and there are a number of algorithms in there, as well as an anomaly detection algorithm, so one that looks at not so much at what clusters together or what can be grouped together, but what events or individuals or rows of data do not match a predefined profile, or do not easily group together with other profiles, and therefore can allow you to detect perhaps, for example, clandestine or even fraudulent behavior. And thirdly, there are association algorithms. We'll see a little example of this is commonly used in what we would call basket analysis, where we can associate products that are purchased together. We've also within Smart Vision Europe used association algorithms to predict what spare parts, for example, are likely to be necessary when an asset fails, when you're trying to maintain a series of assets and an error message is generated. So you can be quite creative with these algorithms and use them for many different things. On top of that, there are a bunch of other algorithms such as feature selection, which helps you identify the best predictors of an outcome. There are algorithms for simulation, for simulating data. There are algorithms for things like survival analysis, where you want to predict the likelihood of an event occurring based upon the time trend, if you like. So there's a bunch of different algorithms in there. We obviously won't have time to go through all of them, but we'll pick a few and hopefully give you a demonstration that gives you a flavor of how it all fits together. There are a rich set of interactive graphics also available that enable things like data filtering, to create fields and recategorization. One of the strengths of PS Clementine Pro is the ability to use the charts and the output itself to create new fields, to define filters, to group categories together without having to drop into code. So that's the interactive aspect of it. One of the core aspects of this type of software is that it doesn't have its own data type necessarily. It doesn't have its own native data file type. If you force it to cache data, for example, it will default to an SPSS file format, but really it assumes very little about the nature of the data you have. So therefore, one could read multiple data sources at the same time in different formats, whether that be text-based, database-based, or spreadsheets, or using native file formats such as SAS formats, Cognos, or SPSS. And it also allows us to automatically build predictive models to try out many different algorithms to find the best one that predicts that outcome. So basically, it does a kind of an automated approach where you can ask it to rank a series of algorithms based upon the performance to help you identify which one seems to work best with the particular data set at time. And we will see a demonstration of that. With regard to exporting predictions and output, the data that you're creating as a result of your analysis, again, you can export that directly to a number of third-party formats, whether that be back into a range of different database types or back out into flat file formats such as Excel or as we shall see, text-based formats such as CSV or tab delimited files. Okay, let's have a little look at a specific example. If I just close down temporarily here, close down the PowerPoint application. I'll just switch to a different view, and if I then just see if I can zoom into that view. In full mode here, where we're using the full view. Let me just make sure I've got full screen mode. Can host F. That's the one switch. That's what I want. Okay. So we're using an image here. We've got a series of different files on it. You'll notice here there's a little link to PS Desktop. That's kind of our launcher application, if you like. So we double click on that, and it launches the PS Desktop for us. Let's just see if I can click it here. Okay, here it is. It's opened up, and it's like a splash screen. It's offering me the opportunity to log in here, so that I have access to the repository, etc. You can see there are other PS products here, such as PS Imago, PS Imago Pro, PS Questio Pro, and PS Activator, which is really the license activator. The only one I've got licensed here is the PS Clementine Pro product, which of course we're interested in. And I'm going to log in at this point, so just log in. I think that's correct. Let's just check. Yeah, so we've logged in as admin. And really at this point, you can see that I could connect to things like the repository in the background, so I could see the objects I've saved. I could also look at job history, if anything that's been run by the PS dispatcher in the background. Yes, just let me check. But if I want to actually launch PS Clementine Pro itself, it probably makes sense for me to simply click New Procedure at this point. And it starts the PS Clementine Pro 2.0. You can see inside it, it's now launching the IBM SPSS Modeler 18.1, which is the core engine that does the analytics for us. And having done so, we get a view of the Modeler application itself. Let me just close this splash screen. And you'll notice, if you've seen Modeler before, it looks very familiar. Of course, you'll notice we've got these extra little sort of green toolbar buttons. These are connections to the PS repository itself. There are, in fact, a couple of procedures that the Predictive Solutions team have added in here. There's one on sources here which allows us to read, for example, PS files, allows us to read multiple text files at the same time rather than reading them individually. And the field ops procedure here allows us to rename fields using search and replace. So it's quite a nice way if you need to rename a whole bunch of fields and remove a character or something like that, or to clean them up. Apart from that, we've got the standard SPSS IBM Modeler procedures and tools on the bottom here, these nodes. So you can see that there's a range of different data sources. All of these circles indicate a data source that one could read. Record operations indicates the level, the sorts of records, the sort of operations we would do to prepare the data, such as sampling subsets or defining a filter or removing duplicates, aggregating the data, merging files together, appending files, etc. Under the field operations here, we have a whole bunch of different procedures which allow us to change the nature of the field, if you like. So it could allow us to, for example, create a new field, or to fill in values in the field, or to change the data structure so that rows become columns, etc. This is very much part and parcel of the entire data mining process. So the data mining process isn't comprised entirely of analytics itself. It usually requires quite a lot of data preparation, and this is an ideal tool to get the data into shape so that we can actually start doing some analytics on it. So I've got some menus here, some triangle nodes here which refer to the different graph types, and then on the modeling procedures, you can see here there's a whole bunch of different algorithms that do, among other things, prediction, that do association, that do segmentation, lots of other stuff. And then we have output nodes, which show us how to evaluate the results that we're creating, export nodes, which allow us to send the results back out somewhere else, a link to SPSS statistics if we want to. We could also have a link to the modeler text mining capabilities, and also some Python algorithms that we can call them, which are now coming in version 18.1 of Modeler. Okay, if I wanted to retrieve a stream, or open up a stream and start a new stream, I could do that at this point, but it turns out that I've got some streams within the repository itself, in the PS Clementine repository. So if I just say open from PS Clementine database, you can see that that immediately launches the PS Clementine database interface. And here we have a repository, and it's searching something right at the top of the repository here called basket analysis. If I say filter the current list, and I typed in something like auto, see if there's anything in there, and hit search for that, it finds it's hold on, let's just click this. Sure, I'm in the repository itself. Search again. Yeah, it finds this example auto classifier. There's another stream here called drug. Say search for that. There's two streams there called drug. This is do analysis of drugs, drug plot. It's a standard stream that comes within the Modeler application itself. If we hit search altogether, you can see all the different streams and objects that I've got within this application itself. So it's, if I wanted to retrieve a particular stream, I've got one here called basket, which you saw earlier on. And I say, you can see here that it's in the repository. It's got no keywords. It's got a description associated with it. There's some version control. There's only one version of this, and it's labeled important at this point. So if I said, okay, well, you know, that's kind of the stream I'm after, I could retrieve that stream and load it into the Modeler application itself. And in the background here, you can see it flashing. Here's that stream that's been loaded in. So at this point, we have a very, very simple stream where we're reading some data, and we've asked it to create a little chart for us. Now, if I show you what the data actually looks like, there are various ways in which you can do that, but if I put a table node up here, I'll show you what the data looks like and run that. You can see that it's a simple data file. It only has 1,000 records in it, and it's mostly comprised of these fields called T or F, true or false, which simply indicate whether or not the individual has purchased within these product groups, within a mini mart or a grocery store, at some point within a period of time. I don't know, the last 6 weeks or the last shopping visit or something like that. So what we're interested in is we're interested in trying to understand what the affinities are between the products, what products get purchased together, otherwise known as basket analysis. And one way in which we can do that is we can visualize it. We can ask for what's called a web plot. It runs a web plot for us and shows us the relationships between the products, whereby the thicker the line, the stronger the relationship. So we can see quite a strong relationship here between beer and frozen meals, and canned vegetables and frozen meals, and a strong relationship here between fish and fruit and veg. And if I want to change how the thresholds, if you like, or how those relationships are defined, I can do so. I can go along here to the controls menu and say, actually, I want to I want to filter out the weaker relationships here. If there was one particular group I'm interested in here, it's like confectionery and wine. I could say generate a select node for that group, and it would generate a little select node for me in the background, selecting only people with confectionery and wine. And then I could go and do a little chart off the back of that and say, well, who are these people? And I could ask it to show me in terms of gender. And when we do that, we find that the majority of them are, in fact, female shoppers at that point. We get a sense of how we can interact with that. So that's very much about insight there. We're kind of trying to understand what's happening, what the affinities are, and we're getting a clue as to what's driving the affinities. But what we're not doing is we're not operationalizing it. If we wish to operationalize it, we'd probably use an association algorithm itself. So if I connect up an association algorithm here, I've got one called Karma, which I can connect up. And I click edit at this point. I can just change some of the thresholds within the model itself. And if I change this down to 8% and change this to 30%, it's very like me changing the threshold values within the chart itself. And if I run that, it produces a nugget for me. You can see there's only 1,000 cases, so it produces it fairly quickly. Though to be fair, it wouldn't have much trouble if there were 1,000,000 cases in there. And if I look inside the nugget itself is the model. If I look inside the nugget, it's showing me the relationships that I saw earlier in the web node, in the web plot, but turned into a tabular format. So here we can see, for example, that if people have already bought canned vegetables or beer, that is the antecedent, then they'll probably buy frozen meals as well. But it turns out that 17.7% of the data is comprised of records where people have bought both canned vegetables and beer. This is known as the support value. And of that 17%, 87% of the time they've also bought frozen meals. So we can see lots of, here's wine and confectionery. 30% of the time people have bought wine, and off that 30%, 50% of the time they've also bought confectionery at the same time. You can see it's driving 22 rules. We can ask for lots of other values to be displayed, including the physical number of instances and what's called the lift value, and I can sort it by any order. So I can say, show me the lift value sorted by lift, where the larger that number is, the greater they are with respect to the baseline. So we're saying that if you bought frozen meals here, you are 2.7 times, nearly 3 times as likely to have bought canned vegetables and beer. If we look at what that's physically creating for us, how it operationalizes, we hit preview across the top here. What we find is that it creates these new fields for us, some of which have null values in them. So the fields are the recommendations themselves. So we're saying that for record number 1 here, you should really offer them the next time they come in. You should offer them wine. If this was a website, something like that, maybe that's what you should surface on the web. It's saying the reason why you should offer it is because there's 52% of people who have bought the products that are in that row buy wine, and it's a rule number 10. And it also has another recommendation that says, well, otherwise you could offer them fish because there's a 31% chance that would be appropriate. And then it doesn't have any more rules for that to trigger for that particular row of data because they have presumably haven't purchased enough in the various categories. Some of the rows have no rules at all, and some have 3 rules, but we can ask and control the number of rules we're going to get. So if we were going to punch that out as a data set, we could export it out in various formats, but what we'd be getting is, of course, 1,000 records sent out back here with various recommendations attached to it. Let me just make sure I attach it downstream of the nugget itself. Okay. So there's the nugget itself, and there we have various records themselves being scored, if you like, to use a technical term, various rules. We have control over the number of rules that we produce to a degree, because we can go back here and we can say, actually, I want to allow you to go down to 5% of the data, so groups that only represent 5% of the data, smaller groups, and in doing so, it creates more rules for us. Now, it created 44 as opposed to 22. So as we change these thresholds, it will create more, we're giving it more freedom to create more rules for us. So this is a very good basis for something like a next best offer, or to identify, associations or natural affinities between products or events or any sort of category. such as product component part failure. Okay, so that's one simple example of how we might use the PS Clementine tool to derive and drive insight for us and to create recommendations or predictions. I've got some other streams here which I can use. I've got one here called auto classifier example, which I said I'd use. This time I'm just opening it from the hard disk rather than with taking it back from the repository itself. If I was happy with this, I would run this stream and say, okay, let's have a little look at this particular data set here. So this data set is a completely different example. This is a very simple data set where we're trying to predict creditworthiness. So we're trying to predict creditworthiness, and we're saying, okay, how creditworthy are these people? Let me just check and make sure that nothing's being held back here. Okay, so we've got this. Connect that up. So look, okay, there we go. So we've got this field here called the credit rating themselves, which is whether or not they're good or bad, which is traditionally how these things are categorized: good credit, bad credit, that type of stuff. We can do a little overview of the data using the data audit node. Here's data audit node, and we can see age is strongly related here to good and bad credit. So good credit here, you can see you get a lot more higher proportion of good credit the older the potential creditor is, or the potential customer is. And here we have income categories, income levels, high, medium, low. They're out of order here, so that's why they're showing a slightly different order here. But you can see that obviously low income has a higher rate of bad credit as opposed to high income. So this is a way for us to check the quality of the data, to see the minimum and maximum values. We actually got a quality tab here. It will identify outliers and extremes. It will impute missing values based upon various techniques, such as rule-based techniques or algorithmic-based techniques. And it gives us a little report on how complete the data is. The data here is complete all the way through. So if we wanted to predict this outcome, we could use a range of different algorithms to do so. So we've got lots of different algorithms we could bring in here. So lots of different algorithms we could predict here, but we don't really know which one is the most appropriate one. So using the auto classifier, we can ask it to try out many different algorithms that are appropriate for predicting this two-category outcome, good, bad. And to make it fair, we've added in a particular node here called the partition node. And that simply randomly stamps the data as either training or testing. And what we're going to do is we're going to build the model on the training group, which it will automatically do once that partition node has been placed there. And we will see how well it performs on the testing group. The testing group, or the group that we've held back from the model, so that we can see, how well would it work on unseen data. It gives us an estimate of how well the model itself would perform in reality. And all I got to do is connect that up to my auto classifier. It automatically recognizes that credit rating is the thing I'm trying to predict, because that's called the target field. I've defined it as the target field in the source node. And if I execute that at that point, it goes off and does that. It's going to build, if you can see it in the background here, it's going to build, let's see, up to 11 models. It takes a little while to do it. And I think I've asked it to retain the top 3. There are various criteria I can use for it to select it. So overall accuracy, number of fields, what's called the lift value, something called the area under the curve value. Lots of ways in which I can say how it should rank and select the best models. By default, when it's downstream of a partition node, one of those trained testing nodes, it tries to select the models based upon their performance on the testing group, which is fairer. That's really what we want to do. The testing group, it's taken a while here to run this. Let's just give it a second. Let's give it a few more moments. And when it produces this, when it's finished at this juncture, very like the last time, it creates a nugget for us. So there it's created the nugget, it's gone through that. And if we look inside this auto classifier nugget, what we should be able to see is the performance of that model. So you can see here that the best performing model according to the criteria that we've given it, which I think was overall accuracy, is logistic regression. And we can see how well it's performing on the testing data set. If I flip to the training data set, we can see that actually this model type, which is linear support vector machine, it's a machine learning algorithm, has performed better on the testing group. Sorry, on the training group. On the testing group, logistic wins. At the moment, it's got this little checkbox column here where it says use question mark. And that means at the moment it's going to use all three of these algorithms, all three of these models it's produced to make predictions. So it's almost as if they're a committee or a panel of voters, and they are being presented with cases, and they're being asked to predict at an individual level whether or not that is a good credit case or a bad credit case. And it combines the groups together, combines their votes together. It's actually called confidence weighting voting. And it will produce a prediction for us. So we can look at the preview value across the top here. And the prediction again at the end here is shown as good or bad. It's got a dollar sign in front of it. And the value next to it is the confidence of that prediction. So it's actually the risk, if you like, of that prediction being accurate or at that time. We can see how accurate it is overall if I connect up what's called an analysis node to that. The analysis node is used to evaluate models. And I can ask for a coincidence matrix, which is just a fancy term for a crosstab. And we can see that in the testing group here, using all three models, 379 of the bad credit group has been correctly identified, where the rows show the actuals, the actual outcome, and the columns show the predictions. 599 of the good credit have been correctly predicted, and the error in the model is shown here at 127 and 110 for the false positive and false negative, respectively. We could have seen that, actually, we could see that pretty clearly in these little charts that are being produced. If you look at the little chart here, it's showing me what the percentage good or bad is. So we can see the error in the model. You can see that the fair proportion of bads being predicted as good and a small proportion of bads being predicted as good and goods being predicted as bad, if you like. So that's just the error in the model. That's what we expect. If I switched off these other algorithms that don't use them and then look at the analysis, it gives me different results. It says overall 80% accurate. If we were happy with that and we wanted to use it in some way, we wanted to use score data, we could do so, or we could pick one of these algorithms. We could go inside it and say, okay, let's just choose this logistic regression algorithm. We could look inside it and see, what's inside that algorithm, how it's performing. So we can investigate it. In the same sense, we could go into this support vector machine and see how that's performing in terms of its predictions, and the same with the neural network. Look inside the neural network, and it gives us a little report here on how it's performing, what its accuracy level is. So each model is encapsulated, but if we wanted to just say use this model and say this is the only one we want to use, we could say model to palette, and it just puts that model in the palette. Okay, so that's kind of how we're finding a model itself. Yeah, so this is how. Now, if we wanted to use it and use this particular model against in the real world, if you like, to create credit scores, I've got another stream here where I've picked this model up. I've connected it to credit applications, and again, if I just hit preview at the top here, what you're noticing is that there isn't a field that tells you the field good, bad, or credit level is not present in the data because, of course, they haven't been assessed yet for the credit rating. So as we send the logistic regression algorithm down through that and it produces its predictions for us, it's producing these predictions because it's based on the same data that the original model was built on, or built on the same factors that the original model was built on, and it's producing our predictions for us. So presumably, we want to select those who are predicted to be good credit rating and not select those with bad credit rating. But if we're being quite conservative about that, we can just say, okay, show me the likelihood as a histogram, if you like, and I can say, well, you know what, we're being quite conservative here, and I want to select everybody, say, above that value there, say above whatever that is. That must be about 0.78 or 777 or something like that. And again, if I right click and say generate a select node for that group, it generates a select node for me for that group. And that's everybody for good credit rating, if you like. And you see it's about above 0.76, so we'll make it rounded up to 0.7. That's 77%, if you like. And we can connect that to an piece of Excel output here, and we can say, okay, just score that and send that out to Excel, and it will create credit predictions for us as an Excel spreadsheet. We could easily have sent it out to a database. We could have exported it back out to a database and indeed read the data from a database. And a range of different databases are, of course, supported at this point. So that's a little tour there through the Clementine, the Predictive Solutions PS Clementine product and how it works. There are many, many other types of analytics we could do, but if we want to now draw our attention back towards the sort of value added capabilities of that product, we can just reduce this application, if you like, and go back here and look at the repository again. So let's go log into the repository again. And this time, when we go into the repository, we just spend a little bit more time having a little look at it. You can see it says Clementine Manager at the top here. There are different folders in this repository. So there are various jobs in there. There are recently used. There are search results that we've searched for. And then within the repository folder itself, you can see I've got various, one here from a bootcamp training course, one here from read only. And basically, depending on who you are, you will have access and read-write rights, if you like, to these different folders. That is controlled down here by the application itself, where we can say the management application. Under the management application here, you can see I've got various logins I can use. I'm logging in as administrator at the moment. I've got my own setup as an analyst here, whether or not the password expires. We've got other ones, test group here. We've got business users that we've used up here. And these can be assigned various roles, whether they're administrators, analysts, read-only, or business users. And those roles, of course, can then be assigned into groups. And we can confer upon those groups various rights and various abilities that they can do. So we can have a lot of control over who can do what and who can alter what within the application. You also see that we've already done a little search here, so we can look at advanced search and look and do wildcard searches, as we've already seen. We can ask it to show us within the repository just streams or just jobs or everything at one point. We can import an object. We can import a folder. We can click on a particular object here. This is a job called deployment, if you like. And we can, we can delete it. We can edit it. We can lock it so that people can't play around or change it. And one of the things we can do is we can go into the jobs itself. So if we go to the jobs themselves, and down here I've got this job deployment here. I've got one here called file trigger, one called basket analysis stream, if you like. So here's a job called deployment, and there's a little stream in there. It's the credit scoring stream that we saw earlier on. So it's exactly the same stream that I did earlier on. It's uploaded with the label latest. And there is a scheduling tab here. So if I look at the scheduling tab, you can see that the schedule type is set to none. I could set it to once, and if I click on once here, I need to edit the stream itself. I need to double click on the job itself and edit it. So let's see, edit the object. Go edit and go to schedule here. I could click on once and say, okay, just going to run it at one time, or I could say daily, and say repeat every 2 days at a certain time, ending at a certain point. I could say weekly, and I can say repeat every X number of weeks and weeks in a day. So I could pick out, let's say every Thursday, every 2 weeks or something like that. And I could even go into monthly here and say, okay, execute, in a particular month on the second day or number of days from the end of the month, and so on and so on. So I've got quite a lot of rich capabilities here with regard to how I schedule it, and it's all through a very nice little interface here. Here's the stream itself, and here's the job itself. And at the moment it's set, the stream is set to schedule. If I go for none, go to job here and say schedule. I could go file. You can see there are other ways in which I can schedule here. I can have a file-based scheduling, and I can also have a web service-based scheduling. Okay, so I could say save at that point. And I could run these jobs. I could run these jobs interactively if I so wished. I could go to schedule here and change them. Let's just double click on that again. And run. And if I hit run, nothing's really going to happen. You're not going to see much happening. But it turns out that in the background, we've got this little tool called the PS Dispatcher, and it's listening and waiting for jobs. So you can see it's constantly waiting for jobs. There's nothing's been found. Suddenly it's found the scoring credit scoring stream, and it says the execution has begun at that point. And we'll wait for it, and it says, okay, no more jobs found to run at that point. And it's also going to come up with, in a few seconds, with information connected to the server. The execution has started. It's saying that the output the screen won't. There's a screen output there. It doesn't have any output for you to create because you're not creating a file off the back of it. But it said that the job execution was successful at that point. So that's an easy way for us to interactively schedule a job. So you can imagine that if you're a business user, you could pick up a job and run it there and then, even though it's been created by somebody else. Here's another job here. We've got the one here called file trigger. So let's just have a little look at that, and we'll just edit that object and look inside it. So this is based on a stream called file watcher stream. So if I just go and find that stream for you, let's just see what it's doing. File watcher stream, here we go. You can see that it's doing the same thing we did at the start. It's new baskets, and it's going to create a file for us that looks like this. Oh, hold on, it doesn't run it. Yes, it's because the file's not there. It's actually I'm going to add the file in a second, but it's basically going to execute this, and it's going to create these next product recommendations for us when we run that stream. So this is the stream that we're going to run. But if I go back and show you how this is running, this is actually a file execution. I call it file trigger. It's in the repository. If I go to the streams up here, and go to the little tab here where it says file monitor, what I'm doing is I'm asking to watch a folder. So watch a folder. Folder could be on a network drive, or it could be on a local drive, and it's waiting for a file to appear. And the file that's waiting to appear can have a certain file mask associated with it. So you could say, anything that ends with XLS and starts with the words monthly report, for example, and has a wildcard in there. In this case, the file mask is just a file called newbaskets.txt. And if I add that file to the C example file watcher folder, it will detect that that file's been added. It will execute the job, and it will of course create the new file, which is the product recommendations for us, and we should be able to see it doing that. So if I just go back out here to the Explorer, and let's see if I can find that file. So if I go into temp here, here it is. It's called New Baskets, as you can see. I can hit Control C just to copy it and go back to C. And there is example file watch folder. It's empty at the moment, which is why it wouldn't run when we run that stream. I hit V at that point. It adds that in. Let's have a look and see what the dispatcher's doing. So I double click on that. And we'll just see if it detects the fact that that file has been added, because that should be a live job. It says, okay, file watcher stream has found it. It says the execution has begun at this point. We'll just wait for it to finish. And this is very powerful, because normally within a lot of scheduling tools, you've really got to write a Python script or something like that to do this. Whereas here it's doing it, and it says, okay, its execution succeeded, and we can see the job history, and sure enough, next product recommendations, which is just a fairly ugly looking text file, is added at that point. So there we are. We're looking at the PS desktop here and looking at the repository and job history. And if I look at the job history here, you can see all of the job history that's been run at that point. So this additional functionality, which is underpinned or driven by the modeler analytics engine, the IBM Modeler and analytics engine, really fleshes it out and makes it very, very much an end-to-end enterprise tool. Here I'm running at the desktop level. I just want to make the point that the repository I'm using is on the desktop, but of course, if we're using, we've got many people who are sharing the repository could easily be on another machine. It's called the distributed mode, and it could be on another machine. People could be loading information, objects, jobs, streams, output into that repository and executing from it at that point. Okay, so that's kind of our little demonstration there that we've got of that tool. Let's return back to the slides. I'll just finish up here so you can see what we've got. So why use PS Clementine Pro? Well, it's relatively easy to use compared to a lot of other predictive analytics workbenches. It's fairly easy to integrate it with existing systems because it's very open. It doesn't really have its own native file type. We've seen some examples there of jobs being triggered by the presence of files. You can also, of course, trigger jobs by, as we say, a web service. Just so that you're aware of that, would be a message that is sent by a third-party application to say, for example, that a process is finished, and that could then trigger a job. So you can very, very deeply integrate it inside existing IT infrastructure. It's very scalable, so you can have server-based versions of it as well as desktop versions of it. And it directly supports integration with R and Python, which I should add in here. SQL pushback refers to the capability which is enabled through a server version of the software, whereby anything that can be turned into SQL is automatically translated into SQL and handed back to the database to do, so that the execution happens inside the database. PS Clementine Pro simply becomes a authoring tool, if you like, of that, and it means that the data doesn't get dragged across the area network, and it means that you're harnessing the power of the database if you've got a lot of CPU power in there. It also enables in database mining. I've just shown you a couple of screenshots here. In database mining is ISW, Oracle, Microsoft, and Netezza are among them, and it also enables text mining if you wanted people to use open source text, open-ended text, or files of text such as emails or documents. You could mine that, turn them into categories, into quantitative data, and use them potentially either to categorize data or to enrich existing predictive models. So PS Clementine Pro offers enterprise predictive analytics, but at desktop prices. And it's got IBM SPSS Modeler at its core, and you've got the prices up there. So you can purchase a 1-year rental license at $1,800 per user plus VAT, or a perpetual license at just under $5,000 per user plus VAT. And you can purchase online by connecting directly to our website. The website here, you can visit the Smart Vision Europe website and add that to a cart and get started right away. With regard to us, well, you can source your software, of course, directly from us, whether it be PS Clementine software, SAS software, or SPSS software. We also provide guided training and consulting, and whether that be in the form of classroom training or side-by-side training support, as well as identification and recruitment of analytical skills in the organization. If you're looking to develop your own analytical capability or set up your own analytical team, you can do so. But generally speaking, we're open to offering no strings attached advice. So if you're interested in kicking around a few ideas with regard to predictive analytics, data science, machine learning, etc., we're happy to do that. And we also offer full technical support services around SPSS and SAS and PS Clementine, whether that be telephone-based or web-based. Okay, I do hope you found that useful. It isn't quite the weekend yet, but it's nearly the weekend. So whatever you do, I do hope you have a great weekend. I do hope you look onto our website and register for forthcoming webinars and web sessions that we've got coming up in the near future. Look forward to logging in again. Thank you very much.